A large refrigerator in a scientific laboratory is always required to maintain a temperature between 0 degrees Celsius and 1 degree Celsius to preserve the integrity of biological samples stored inside. A scientist working in the laboratory suspects that the refrigerator is not maintaining the required temperature and decides to record the temperature every hour for 7 days. Based on these measurements, the scientist concludes that the temperature T in the refrigerator is normally distributed with a mean of 0.8 and a standard deviation of 0.4. Temperature in degrees Fahrenheit is given by this. Determine the mean and standard deviation of the refrigerator temperature in degrees Fahrenheit. Okay, so all we need to do, the mean was 0.8, so we'll do 9/5 times 0.8, add 32, so that's 33.44 degrees Fahrenheit. So that's the mean. And standard deviation, of course, is in the same units, so we can use exactly the same formula here. We just need to multiply by 0.4. This is 2022 me, just interjecting to correct a mistake that 2021 me made. When we're calculating the standard deviation, of course, the addition of 32 should not happen because moving us left or right doesn't actually change the dispersion. So the 9/5 times 0.8 plus 32 is correct for the mean, but for the standard deviation, it should just be 9/5 times 0.4. I'm about to make that mistake. It's 32.72. Determine the probability the refrigerator temperature is above 1 degrees Celsius. Give your answer rounded to 4 decimal places. Okay, so we're just after the probability that the temperature is more than 1. So, normally distributed. So we're going from 1 up to infinity. And our sigma was 0.4 and our mean was 0.8. And so that's 0.3085. There's quite a big probability of it being outside the range. The histogram data gathered by the scientists is shown below and denotes the number of observations in each temperature interval. Do you agree that the normal distribution was an appropriate model to use? Provide a reason. I'm going to say no, because we know that normal is symmetric, but if we look at our data, it doesn't have any of this tail. What we have here is positively skewed data. So that would be my answer. I would not use it because the data appears to be positively skewed. Okay, let's go and find the next part of this question. An alternative probability density function proposed to model the refrigerator temperature in degrees Celsius is given by this. Determine the probability that the refrigerator temperature is above 1 degrees using the new model. And we can see t is from 0 to 2. So that seems to me that we would use the integral from 1 to 2, so those are all the temperatures that are above, of this. And we can do that on the calculator because it's a calculator paper. So, which is why you're not being given many marks for doing it. So we've got 1 to 2 of 3/4 of x cubed minus 3x squared at 3x dx, and that's 0.3125.